Hi guys! So in this video, we're just going to go over some problems for adding and subtracting polynomials, as well as multiplying monomials times polynomials. Alright, this is just going to be solving problems. Let's go ahead and get started. Now remember, when you are adding and subtracting polynomials, two things keep in mind. Number one, take the sign with you. Okay, make sure that you are keeping track of your signs. Number two, combine like terms. Okay, you can only combine like terms. In this case, you can only combine variables with the same degree or power. So in this first problem, I have a 5x squared and I have a negative 3x squared. Those are like terms, so I can combine them and get 2x squared. Change color so you can see what's going on. Next, I have 3x, or negative 3x, and then I have 6x. Negative 3x plus 6x, that's going to give us plus 3x. And then last one is I have 4 and a negative 3, that's going to combine to a plus 1. So I have negative 2 squared plus 3x plus 1 as my final answer. All right, let's go over here to subtraction. Now on this one, remember, subtraction. You are subtracting one polynomial from another polynomial. So the thing to remember here is that you have to distribute this negative, this subtraction, to every single term. Every single term must be subtracted. And that's what I meant earlier when I said take your signs with you. You have to remember that subtraction goes to every single term. So my first step is just going to be rewriting. Okay, minus 7 plus y cubed. Whoops. All right, minus 12y. Okay, so make sure your signs go with you. Next, I'm going to look for the highest power. Change colors. Let's see. Y cubed is my highest power, and I don't have another y cubed. So y cubed is going to go up front. My next highest power is y squared, and I don't have another one of those. So plus 5y squared. Then I have 8y, and I have negative 12y. Okay? 8y minus 12y, that's going to be minus 4y. And then last but not least, I have negative 10 and negative 7, which is going to give me a negative 17. Now notice how I only combined the like terms, okay, the terms that had the same degree. Also, notice how I ordered my answer. Highest degree goes up front with the constant in the back. Okay, make sure your answer is always ordered like this. And this is my answer. There are no more like terms for me to combine. This is as far as it goes. You can put a box around it and move on. All right, the video is going to pause. Try to do these two problems, and when it plays again, you'll see the answer. All right, and here are my answers. Now, in the first one, as you can see, I changed colors so that you can see my like terms. In the second one, I used different styles of grouping. Okay? Make sure you are only combining like terms. So if you have to mark them the way I did in that second problem, do so. All right? A very common mistake here is to see x squared and for some reason read x cubed, okay, or to mix up the degree somehow. But always be very, very careful that you are combining like terms with like terms. All right, now we are moving on to multiplication by a monomial, okay? Now, when we start multiplying next lesson by binomials, things change a little. But monomials, it's still relatively simple. Let's do a quick example problem. Let's say over here in the right corner, I have 3 times x plus 1. Okay, well, we should know how to handle this one. I'm going to distribute my 3 to both, and that's going to give me 3x plus 3. No surprises. Let's say let's switch things around. Let's say I have x times 3 plus y. Okay, I'm going to distribute my x. Same rule applies. And now I have 3x plus xy because I multiplied. Okay? So whenever you have a monomial up front, you have to multiply it to every single term in the parentheses. You have to distribute. But let's not forget our exponent rules from last chapter. Let's say I have x, and let's go with 3 plus 2x. Why not? When I distribute my x to the 3, that's 3 times x, which is just 3x. But then when I distribute to the 2x, remember that when you are multiplying your bases, you must add the exponents. So now I have plus 2x squared. Okay, and then you would need to reorder to put things in terms of degree. Okay, so when you're multiplying, the next thing you have to keep track of is your powers. Keep track of the degrees. If you are multiplying a variable times another variable, make sure you are still obeying the exponent rules. Okay, let's do this first problem. We're going to go slowly and we'll see what happens. So for this first one, I have to distribute the 3 into the whole parentheses. So that one goes there, there, and there. Okay, so 3 times 5x squared is going to be 15x squared. 3 times 2x is going to be plus 6x. And then 3 times a negative 4 is going to be negative 12. Okay, change color so you can see this next bit. Now, the term that I am distributing is negative x. Okay, remember, take the sign with you. So that's negative x times 7x squared. Okay, so numbers first. Technically, I've got a negative 1 up here. So now it's going to be negative 7. And then I multiplied my basis, so I need to add my exponents. X cubed. Okay, negative x goes to the next term. Again, I'll have a negative 2. And then I add my exponents, and that's going to be x squared. Last but not least, to the back term, a negative times a negative is a positive, so plus 3. And then there is no variable, so x just comes on down. Okay, make sure you take your sign with you, and then make sure you are doing the exponents properly. Make sure you obey all rules. Now let's go ahead and just combine like terms. So my x cubed is the highest power, so negative 7x cubed goes up front. 15x squared, and then negative 2x squared. This is going to give me a plus 13x squared. 6x and 3x. Plus 9x, and then negative 12 doesn't have a buddy, so it just comes straight on down. Okay, and that's your final answer. Nothing else can be combined. That's it. All right, now, next one. Do it again. So again, I'm going to distribute. Now, pay attention to your base. This is a t, which means I can only combine it with other t bases. So when I distribute, my numbers are going to be multiplied. So that's 150. The y cubed, nothing happens to that. It just comes straight down. I'm not multiplying by a y, so it doesn't change. I do, however, have t to the first power times t to the 5th power. And when I multiply my bases, I add my exponents. So that's going to be t to the 6th power. Distribute again. Okay, now I have 15 times 5, and that's going to be plus 75. Again, nothing happens to my y, so it just comes straight on down. And then I have t1 times t to the 1 again, which means I have t squared. Okay, now notice I can't add these two things. Okay, I started with a binomial in the parentheses, and I still have a binomial. In order to combine these two terms, the numbers, the variables, would have to match exactly. I would need a y cubed t to the 6th power in both, and I don't have that. So, as you have multiple variables in your problem, make sure you pay attention to them because they have to match exactly in order for you to combine like terms. All right, do this again. So I have a negative 2y, and I'm distributing. So this is going to be a negative 2 because there is no number, which means it's a 1. So negative 2 Now I have a y. So y to the first power times y to the first power. It's going to be y squared. I don't have a t in this bit, so t squared just comes straight on down. Next term, negative 2 times 4 is going to be a negative 8. And then a y to the first power times a y to the second power. Add my exponents, and I get y to the third power. Okay? Now I'm going to check and see if anything does match exactly. So check for y cubes. Well, there is one y cubed back here, but it doesn't have a t to the 6th power, so can't do that one. I do, however, have these two. 75y squared t squared and negative 2y squared t squared. They both have the same y squared t squares, so I can combine these. I'm going to bring everything else down. Okay, and then it's going to be plus 73y squared t squared minus 8y cubed. And that's my final answer. All right. Now, when we are solving with polynomial expressions, biggest thing I want you to remember is this is just a regular equation. Yes, we've added more things to it, but the basic rules of PEMDAS still remain the same. Okay? Address your parentheses first. Look at the exponents next. Multiply and divide if needed. Add and subtract as you have to. Okay? Treat it like a regular equation. Here we go. So this first one, I'm going to distribute my 2x to both terms. Okay, 2 times the 1 up front is just a regular 2. X times x is x squared. Next term, 2x times 4 is going to be plus 8x. This positive 7 plus 7 just comes straight on down. Is equal to, my x plus 8 comes straight on down, and I can get rid of the parentheses. Okay, those parentheses are just there to throw you off. There's nothing being multiplied or added or subtracted to it, so it can just come straight on down. Plus, all right, I got another parentheses, so here I go. I'm going to distribute to both terms. 2x squared again, plus 2x. And then my 12 comes straight on down. Okay, notice how the only step I technically did in this first go-round is distribute into my parentheses. That's all I did. Now I'm going to combine like terms if I can. On my left side, there are no like terms to combine. But on my right side, I got a few things. So I have an x right here and a 2x right there. I have an 8 and a 12. So I'm going to go ahead and combine those terms. My left side just comes straight on down. I'm going to change colors so you can see this. My left side just comes down. Nothing happened. But over here on my right side, I have x plus 2x, which is now 3x. And then I have 8 plus 12, which is 20. And then 2x squared just comes on down. Okay. Now, just like any other equation, I need to get my x's on one side of the equation. So first thing I'm going to do is deal with my x squares and hope they go away because we don't know how to deal with them just now. So I'm going to subtract 2x squared from both sides. And lo and behold, they do go away. They go away from both sides. Now I am left with 8x plus 7 is equal to 3x plus 20. And this should be looking like a more manageable equation. Minus 3x, minus 3x, minus 7, minus 7. And I have 5x is equal to 13. Divide by 5, divide by 5. 13 over 5 is my answer. Put a box around it and walk away. Don't turn it into a decimal. Leave it as a fraction. Fractions are numbers too. Be nice. All right, you try this next problem. When the video plays again, you'll see the answer. How'd you do? Now, I have it boxed, kind of, right here. But when you distribute, you end up getting a d squared and then a negative d squared. D squared minus d squared, it ends up canceling out because 1 minus 1 is 0, or d squared minus d squared is 0. So that ends up canceling out, and then you're left with this equation right here. Combine like terms on one side of the equation just to keep your math simple, and then make sure that you are being very careful with your signs as you go on down. All right, these are all the problems we were going to go over today in this lesson. Good luck on your homework, and I'll see you next time.